Sorry, I'm really struggling here. Let's go minus 36. Okay, and it just said to factor.
Could you use GCF for this one?
There's no GCF.
Okay.
We'll get to some GCF stuff in a bit.
Did you do the one with the little X?
So this is there's a 1 in front of x squared. And that's your clue that you're looking for two numbers that multiply to the last but add up to the middle one. So two numbers that multiply to minus 36, but they have to add to minus 9.
Minus 9. Okay.
Like think of minus 36. You've got a lot of possibilities. 1 and 36, 1 and minus 36. And then minus 2 and 18, 2 and minus 18. But you don't have to write them all down. You just have to get the one that's correct.
Okay. And there would be like 3 and 12, right?
That's right. And which one's positive? Which one's?
Oh, 3 and negative 12.
Yes.
So
this becomes x plus 3, x minus 12.
Yeah. Okay. So what kind of factor would that be?
Well, I call it a equals 1. It's it would be like I guess if on your quiz there, it would be like problems 9, and then I saw one in the back like it. It's like 9 and 2 and 9.
2 and 9.
Yeah. It's a trinomial. I guess well, you're looking for the classification. I don't know the way your instructor does it.
Oh, would it kind of be like AX plus?
This is really an x squared plus bx plus c.
Yeah. Okay, yeah.
I guess that's probably how he's doing it. So that's this type.
So standard form trinomial.
Yes.
Yeah, okay, cool.
So here's another one for you to think about. X squared minus 19x plus 60. This is the same form.
Okay. So x squared minus 19x plus 60. So two things that add up to multiply to 60, add up to 19. So there's 6, negative 60 and 1. Negative 1 and 60. There's negative 2 and 30. 2 times negative 30. 3. Oh, no, 3 and negative 20. That be it? No. Okay, and then 4 and 15. There we go. Wait, no, that's 11. Negative. Oh, okay, so it's 4 and 15.
Yes. But what are the signs here?
Oh, so x plus 4.
Nope. They're both. The only way you can get to positive 60 is 4 and 15 or negative 4 and negative 15.
Oh, 4
Okay.
and 15.
And you need the one that adds to negative 19.
Oh, negative 9. Oh, yeah. Negative 4 and negative 15.
Yes.
Okay.
So x minus 4, x minus 15.
Okay.
Okay. Now you mentioned something earlier, and I guess I should have started there. I didn't quite know where to begin this lesson because it's a pretty broad coverage. But the first type of factoring you're always looking for is GCF. You're always looking for GCF first because it's the best possible situation. Okay. So let's do a problem where it's got GCF factoring -3. Let me actually see here. Does your instructor switch letters? Didn't notice at first glance. Yeah, he does. Okay. -3 m squared minus 6m plus 72. So does this have a GCF? Is there a number that goes into all three terms?
Yeah.
Okay. And what is that number?
3 and m.
Just the number. There's not an m in all three. There's only an m in two of them.
So just 3.
-3.
-3, yeah.
So tell me what goes inside parentheses here.
M squared minus 2m.
Plus 2m because the negative, you're dividing each of these by -3.
Yeah, okay. Plus 2m plus that would be, I'm sorry,
Take your time.
-24.
-24,
Yeah.
right? That's easy to mess the signs up. Now the one inside parentheses is in that form x squared plus bx plus c. You're looking for two numbers that multiply to -24 but add +2.
Would it be 6? No, not 6 and 4. 3 and 8. -3 and 8.
Well, those work to multiply to -24, but do they add the +2?
Oh no. 12 and 2. That doesn't work. 8 and 3 doesn't work. Oh wait, it's +2.
+2, yeah. So
Oh, okay.
one of the things that I'm not hearing is like a nice organized list where you sort of start increasing, 3 and 8, 4 and 6. These are the only possibilities. And writing down the list will help you to determine the numbers.
Oh yeah, okay. So would it be 4 and 6?
Yeah, which one's negative, which one's positive?
4 is negative and 6 is positive.
So m plus 6, m minus 4, like that.
Yeah.
Does that work?
Mhm.
Okay, you ready to do one on your own here?
Yeah.
All right, -2n squared minus 6n plus 108. I'm going to just step away for 30 seconds or less. Just be right back. We'll go ahead and start working on this. It does have a GCF. It is just like the last. All right, Max, I'm back. Can you tell me what you factored out as your GCF?
I got -2.
Okay, and what goes inside parentheses?
N squared plus 3n minus 54.
Good. Okay. So two numbers that multiply to -54 but add to +3.
54, there's 54 and 1, and there's 30, there's 37 and 2, and then there's 5 and 6. No, wait, 5 and 9. No, wait, no, 6 and 9. Sorry. 6 and 9. And then 40.
The other thing to consider is that when you found the ones that are correct, you don't have to keep going.
Yeah.
And you have told me it is some combination of 6 and 9, right? One's positive, one's negative.
So would it be -6 and positive 9?
Yes. So what goes in parentheses here?
6 plus
Tell me
sorry,
variable first. Usually the variable comes first. N plus
n plus 6 negative. No, n plus 9.
N plus 9 and
N-
minus 6. And it would also be okay to put N minus 6 and plus 9. That would be okay as well if you wanted to switch the order.
mm,
Is that okay?
Yeah.
All right, let's do one more before we move on here.
Yeah.
4v squared minus 4v minus 8. I want you to factor this for us,
Okay.
please.
So that would be factor 4. And then that would be v squared. Minus v minus 2 x minus 2.
Keep in mind your letters are V this time.
Oh yeah, sorry. V minus 2 and v plus 2. No, plus
Okay.
1.
V minus 2, V plus 1. Don't forget to bring the 4 down. I
Yeah,
got it.
and 4. So you don't have to put the 4 on each parenthesis?
Just one, it's multiplying. The multiplication, you only multiply one of them. That's why it's only in one place.
Okay. Cool.
Right. Good. So now we're going to move on to ax squared plus bx plus c type factoring. This is where the first one is not a 1.
Okay.
All right. And it's going to require a little bit of a different approach than we've been doing. I'll show you a couple examples and see if it makes sense here. So sorry, I didn't mean to slide that so far. 2x squared plus 3x minus 9. So when you have a number in front and there's no GCF, there's not a number that goes into both 2, 3, and minus 9. Okay.
Mhm.
You have to take a look at the first and the last. You have to take 2 and multiply by minus 9. 2 times minus 9 is minus 18.
Okay.
Okay. Now you're looking for two numbers that multiply to minus 18, but add to positive 3. Can you think of those two numbers?
Add to positive 3. 99, 3 and 6.
3 and 6. So it's actually a positive 6, negative 3.
Yeah.
And then what you're doing with this 3x is you're breaking it apart either to 6x minus 3x or minus 3x plus 6x. And you have to pair it now with the 2x squared. And my question to you is which line pairs better? Does the 6x pair better with the 2x squared, or does the minus 3x pair better with the 2x squared? If you're
Oh, sorry.
And if you're not sure what I mean, I can pick for you. I just, this is kind of how I show it. So it could be first time you're seeing it.
Is this for like the factor by grouping thing?
Yes, exactly.
Okay, so you want to keep like the factors together, right? Like one's
Well,
that.
like they both work, but one might look better to your eye than another.
Yeah, I think the first one looks better.
Okay, I kind of agree. Now you look at the first two terms and you see what is the GCF between them? What goes into both 2x squared and 6x?
2x, 2x.
And 2x. And so what goes in parentheses here? What, when you divide each of these by 2x, what does it become?
X plus 3.
Okay, and then here's what you do. You immediately write x plus 3 over here to the right, and you figure out what goes in the middle.
Okay.
So what goes here such that when you multiply in, you get back to minus 3x minus 9. Sometimes it's better to just look at the constant to get that answer.
-3.
-3, yeah. All right, now both of these have an x plus 3 in them, which means it would be a good idea to factor out x plus 3 from both. And then you bring the 2x down, the minus 3 down, and you are done.
Oh. Okay, I'm gonna write that down.
Yeah.
So that one is factor by grouping. So the original problem was 2x squared plus 6x minus 3x minus 1. And then you want to we want to break them up first, first, and then you want, so you break these up. Okay. So then after you break it up into pairs, you find the factors, right?
When you say pairs, do you mean the ones on the right?
The ones in
Which
the parentheses.
which line here? 1, 2, 3, or 4?
2.
Okay, yeah, you figure out which one pairs better, with it, and then you use a GCF right here.
Okay, cool.
Okay, because we're gonna do another one. Just stand by. Let me know when you're ready for that.
By grouping for each one, let's see. 2x, x plus 3, and then maybe 3, x plus 3. And then you just bring it down and okay, I'm ready.
So our new problem here is 3n squared minus 8n plus 4. Okay, so you always start your list. Is there a GCF? There's no GCF. There's not a number that goes into 3, 8, and 4. No letter. Then you get through a few others, which maybe I'll get to. But this is the a not equal to 1, the grouping problem. All right, which means you take the 3 and the 4 and you multiply those together. 3 times 4 is 12. You're looking for two numbers that multiply to 12, but add to -8. Could you calculate those two values, please? Multiply to 12, but add to -8.
Add to -8. So add to 12. Okay, factor to 12. 3 and 4, 12 and, oh wait, no. But do it in order. 12, 1, and then 6, 2, 3, 4. Yeah, okay, so if I add to the 8, so would it be 6 and 2?
Yes, but those add the positive 8. You want negative 8. What
Oh,
change should we make to those two numbers?
you should turn them both negative.
Yes. All right, so I'm going to help out. We're going to pair it as minus 6n minus 2n plus 4. The 6 pairs better with the 3 than the 2.
So it's this one?
So now you're going to factor the GCF out of the first two.
Okay. Wait. Oh, so you just break the
You
8
break the
and,
middle one apart, yep, and
oh,
then use the GCF factoring on the first two.
okay, so you just like, wait, so, oh, okay, so you multiply the two n numbers together to get 12, then find the greatest common factor that adds the middle number, then you use those numbers to break it in half.
Yes.
Okay, cool. All right. Thank you. And then so 3n squared minus 6n minus 2n plus 4. So that'll be 2n parentheses. Minus 3n parentheses n minus 2n parentheses negative 2 and plus minus. Okay, so is the answer 3n parentheses n minus 2n close parentheses negative 2 parentheses n minus 2.
Good so far. There's one last step. You have to factor out the n minus 2 from both. Do you understand what I mean by that or not? So this 3n comes down because it's part of the first term, and then the minus 2 comes with it. But they both have an n minus 2 in it. There's a n minus 2 in both, and that's why it comes out.
So the 3n comes down to the opposite one.
Well, yeah, I don't want to say this. It's like because it's in parentheses, it's like a number. It's in both. That's why it can come out. And then what's left over is the 3n, and the minus 2. They're now paired together.
Okay.
I didn't do a good job. Let's try it. Let's try again here. So let's say it's 4 5x plus 1 plus 3 5x plus 1. This is 7 times 5x plus 1. Do you agree with that? Because you got 4 of them and 3 of them.
Yeah.
Now, if you factor the 5x plus 1 out of both, you bring the 4 down, you bring the 3 down. What does 4 plus 3 become?
7.
7. And it still works. So if something's in both, you can factor it out and add the other stuff. If you can add it, like in your problems, we can't add it. We're just rewriting stuff like that.
Okay.
Okay, I want you to try one on your own here. It's just like the last two, just more for you to try.
Mhm.
Ask me some questions if you've got them, or
Alright, cool. So I have to break the middle part up, right?
you first have to notice that there's no GCF and the leading term is not a 1, so you have to multiply the 3 and the -5.
Oh, so when the leading term isn't one, you have to multiply the two outer numbers.
Yeah,
Oh, okay. So that would be -15. And then you have to find the factors that 2, 3, and 5. 5 has to be negative. So that would be 3p squared plus 3p minus 5p minus 5. Put those in parentheses. Find the GCF, 3p, that would be just p, and then that would be plus 0. That would be -5. And whoops. Parentheses p plus 0. And then it would be p plus 0, parentheses, second set of parentheses, 3p minus 5.
heard a 0 somewhere. Did did you did you actually say 0? I'm not sure if I caught that.
Yeah.
Okay, so the -2p gets broken down into -5 plus 3. So 3p squared plus 3p minus 5p minus 5. Does this match what you have?
Yeah.
So there is a 3p that goes into the first one. It's p plus 1, p
Oh,
plus
yeah.
1.
Yeah.
So when it divides, it doesn't, it's not that it's 0, it's
Oh, okay. Because it's just like like the fraction, it's even on both.
if it's the same on the top and the bottom, right? 3p over 3p is 1 over 1.
Okay, that makes sense. All right. Okay. Cool.
Okay, so the last step here is it's p plus 1 times 3p minus 5. You think we should do one more of these?
Yeah.
Is it okay if we do one more?
Sure.
Or I have you do one more? Okay. We'll make it all positive so there's no signage. 5x squared plus 19x plus 12.
Okay. Well, the first term is not 1. One by the other terms, which is 15. And 1. And will be in 2, in 4. Okay. Equal 19. So you would have 5x squared plus 15x plus 4x plus 12 plus yeah, 5x is yeah, x and then 3 plus 3. Okay, and then it would be 4 yeah, x plus 3 then you would have x plus 3 parentheses, 5x plus 4.
I'm sorry, do you have, is that, what is your final answer?
X plus 3 parentheses, in parentheses, and then 5x plus 4 in parentheses.
Good, very good. Okay. Let's next talk about perfect square trinomials. I saw a couple of those on your test.
Yeah.
So a perfect square trinomial looks like something like, let's build up to it. So let's say it's x squared plus 12x plus 36. This becomes x plus 6 squared.
Oh,
Okay.
so you find the GCF of the first two numbers?
Well, the GCF is just x. It's actually the square root of x squared and the square root of 36.
Okay. Oh, so the
This is called a perfect square trinomial.
okay. So it would be x squared plus 12x plus 36. And then the answer would be
So this is it. This is the answer on the right.
okay.
We're gonna do a few more to kind of get you to see how these things work. So let's say I gave you something that's like y squared plus 20y plus 100. What would go in parentheses over here?
It would be y plus 10.
Very good. Okay. Squared.
Squared.
All right. Now here's some other things I can do. I can put something like this: 4y squared plus 4y plus 1. And this becomes 2y plus 1 squared. So sometimes you have to take the square root of the first, and it's more than just one thing.
Yeah.
But the square root of 1 is 1. So that's where these come from.
Okay.
So let's have you try a couple here. See if we can get this down. Here's one for you to try, please.
16x squared plus 40x plus 25. So for the trinomial square, you don't have to make the x equal the first number to be equal to 1.
No, in fact, you're looking for things that you can take the perfect square root of.
Okay, so it's only
That-
for the other one.
Yes.
Okay. So the perfect square, so that would be square root of 16x squared parentheses plus square root of 25, sorry. That'll be 4x plus 5 parentheses squared.
Like this.
Yeah.
All right, very good. Let's have you try another one here. Let's have you try. I'll just write this one: 36 x squared plus 60x plus 25. What does this become?
That will become 6x plus 5 parentheses squared.
Good. Okay, now there's another variation on this, which is that, well, so here are the two forms of a perfect square trinomial: a squared plus 2ab plus b squared equals a plus b squared, or a squared minus 2ab plus b squared equals a minus b squared. What is the lone difference between these two? It's the only difference that you see, hopefully.
One has a plus, one has a minus.
That's right. Okay, so let me give you a couple of minus ones here to try before we move on to some other stuff. What does this factor into?
It factors into 10b. Plus 9. Minus 9.
But there's a negative here,
Oh, so minus 9?
minus 9.
Okay, so if there's a negative anywhere in the question, it's a
Well, not anywhere. It's the first one here.
okay, yeah, okay. Cool.
Okay, so here's another one for you to try. R squared minus 22r plus 121. What does this become?
It would become R minus square root of 21 or 121, which is so is it 11? Yes. Okay.
All right, now the last type of problem you might see is where they introduce two variables. So 49p squared minus 28pq plus 4q squared. But it's the exact same process. You take the square root of the first one and the square root of the last one. And that's what tells you what goes in parentheses.
Okay. Yeah, that makes sense.
So can you try this one for me, please, and let me know what you come up with?
Yes, it would be 7p minus 2p parentheses squared.
2q.
Sorry.
Okay. Let's have you try one more of these. Let's go 121 n squared minus 110 nm plus 25 m squared.
That would be 11 and minus 5 and parentheses squared.
Good. Okay. All right. So that's we've done a lot of the factoring that you've seen on your test. Let me just scan through it. Everything on that page we've done those types. The last one is a GCF. We need to look at some GCF problems.
Okay. GCF problems.
Yeah. So let me give you just a pure GCF problem here, nothing else. And then maybe we'll go through a couple of your test questions again. So let's go 18 x to the fourth y cubed minus 21 x squared y the fourth plus 6x squared y. So there's only a GCF here. The GCF can be a number, it can be a letter, a variable, or it can be more than one variable. You really want to look at the 18, the 21, and the 6 and decide what number works, then the x to the fourth, x squared and x squared, then the y cubed, y to the fourth, and y.
Okay. So would it be 3x to the 2 y outside of the parentheses?
Yes. Then you got to figure out what goes in here.
Would that be 6x to the 2 y to the 2
Okay, good.
minus 7y to the 3?
Good.
plus 2, well, 2 plus 2.
You got it.
Cool.
All right, that's excellent. Okay, so let's look at a couple of problems that you had on your test here. Let's look at, and I'll just kind of make it a little different. Let's go, yeah, u to the 6th plus u to the 4th plus u squared plus 1. So we didn't look at anything like this today, but we did look at some problems that had 4 terms. Problems with 4 terms. Do you remember how we looked at the first 2?
Yeah.
Okay,
Was that factor by grouping?
this is a grouping problem, yes. So could you give this a try?
Yeah.
Figure out what factors in the first 2.
Would it be u to the 2?
Bigger. What's the biggest exponent that goes into both of these first 2? Just the first 2. You don't care about the other ones.
Oh, u to the 4.
Okay, so put a u to the 4th on the outside. What goes on the inside?
U to the 2 plus 1.
Okay, and then you immediately write that over here.
Oh, and then
What goes in between?
just 1.
Plus 1. This becomes, what does it give me the next line here?
That would become u to the 2 plus 1 in parentheses. Second set of parentheses would be u to the 4 plus 1.
Good. All right. Fantastic. Okay. Let's see, what else do I see on here? It's a good one. 6p squared plus 54p plus 120. What is the first type of factoring that you should always look for? What's the most important? GCF. Is there a GCF?
Yeah.
Yes. Is there a number that goes into all 3? Yes.
Yes.
So let's just say you didn't know and you guessed 2. Okay. 3p squared plus 27p plus 60. But you said, well, I think 3 goes into all 3. Well, factor out of 3. P squared plus 9p plus 20. And now you can multiply the 2 and the 3. That's 6. And maybe you would say, oh yeah, I should have known that it was 6. P squared plus 9p plus 20. Can you factor this for us, please?
That
The
one,
middle, the part inside parentheses. This is a x squared plus bx plus c.
that one would be like, oh yeah, it's the one that's like, yeah, okay. So it would be factors of 20, 20 and 1, 10 and 2, 5 and 4. Okay.
You got it.
Yeah, okay, that's it. And
What is the
then
answer?
p plus 4, p plus 5.
Very good. Sorry, 5. Yep. Okay. Let's see if I can grab one more for us to look at here. All right. So we've got 2y squared plus 5y plus 3.
That would be, oh yeah, you have to get you have to multiply, that would be 6, that would be 6 and 1, that would be 6 times -1, that would be y.
So two numbers that multiply to 6 but add to 5.
6 is times -1.
It's got to multiply to positive 6.
Oh,
So they're both positive or both negative. In this case, they should be both positive because of the plus.
they are both negative. Right.
It's positive 5. There's no way to get a positive 5 from two negatives.
Oh, yeah, okay. So positive.
So we got 2 and 3. So it's 2y squared plus 2y plus 3y plus 3.
Yeah.
First one there becomes 2y times y plus 1. Y plus 1. And then what goes in the middle here?
That would be 1.
You got to get back to 3y plus 3.
Oh, that would be 3.
3. Okay. So now you're almost there. What's the final step here?
You would just do y plus 1 in parentheses, then you would do 2y plus 3 in parentheses.
You got it. All right, very good. We're going to go ahead and stop right there for tonight.